All right, so the first thing we're going to do is we're going to do a little review here. So we take a look at the periodic table. The periodic table, of course, represents the symbols of the elements found around the world that we know. So here we have hydrogen. And depending upon your periodic table, you have two different numbers. You have the top number, which is the atomic number, which represents the number of protons. And the bottom number here represents the atomic mass number, which is the total number of protons and neutrons. So depending upon your periodic table, the atomic number here and the atomic mass number here, they can actually be switched around. So make sure when you're looking at any type of periodic table, you look at the key so that you know which number represents which. So taking a look at hydrogen here, it has one proton, and then the bottom number here, the atomic mass number, represents the number of protons and neutrons. So there's only one proton there. There's no neutrons. Like, well, what if we had something else? Let's say we had helium here. Helium is it. So how many protons? There should be 2. The atomic mass is 4, so how do we find out how many neutrons does this atom have? Well, here we have, to find this, we take the atomic mass number here minus, whoops, I want to do that, minus the atomic number, and that will give us the number of neutrons. This is all review. So we take the atomic number, we have 2 here. The atomic mass for helium is 4, so we subtract it. So therefore there are 2 neutrons in helium. Well, so this is the nucleus of the atom. We're going to now take a look at the electron part, the main part of the lesson here. So we take a look at this. Of course, we talked about how the electrons are found in something called the electron cloud. Electrons are found outside the nucleus. And because they're traveling so fast, we don't know exactly where they are. And so therefore, it kind of looks kind of hazy, like a cloud. Well, we're going to represent these. We're going to call this the Bohr model. All right? And what happens is we're going to say that electrons travel around the nucleus like planets. All right? And the sun being the nucleus, where the protons and neutrons are located, and then the electrons will be our planets, where they kind of rotate around. Now, looking at the model here, each ring is considered a main energy level, and each level can hold so many electrons. The first main, this is important, we're talking about the main energy level. The first main energy level holds 2 electrons. The second main energy level can hold 8 electrons. The third main energy level can hold 18, and the fourth, 32. Now, these are the main energy levels. When we take a look at electron configuration, we take a look at how many protons or how many electrons each atom has and where they're located in these outer rings. And the way they fill in, it feels kind of like they start from the inside and they work their way out. As we take a look, electrons closer to the nucleus have less energy in them. So electrons on the farther out have more energy. Think of it this way. When you're on a merry-go-round and it's going really, really fast, if you're closer to the inside, do you have to hold on tighter? Or do you have to hold on tighter when you're farther away from the center? Well, it takes more energy. You have to hold on tighter farther out because otherwise, you just get spun off. Well, the same thing is happening with electrons. So we look at these main energy levels, and we're going to go to the next one here, and this is representing another atom where we're going to find out and fill in these electrons. What they do, like I said, they fill in from the inside, and just like a cup that overflows, as that first main energy level gets filled, it spills over into the second main energy level, and then into the third, so forth and so on. We take a look at the number of electrons. We take a look at the main energy level. Each main energy level is like kind of like a floor in a building. And each floor isn't, like in the high school, for example, the second floor isn't just one big, huge, long room, right? It's subdivided into smaller rooms. Well, the main energy levels are actually subdivided into smaller sections, and each section is a different size. So we take a look at this, and helium, or let's start with hydrogen. Hydrogen has, take a look at your periodic table. It says it has a proton, its atomic number of 1. So it has 1 proton. Does it have any neutrons? No, there are no neutrons. Therefore, the number of electrons hydrogen will have will be 1. So what we do is we just we'll represent electrons with an E, and they have a negative charge, so we'll put a negative sign there. So it goes like this. Now helium, we take a look at helium. Helium would have, or let's move on. Let's go on to, say, lithium. Lithium has an atomic number of 3. So it has how many protons? It has 3 protons. Well, how many neutrons does it have? Well, its atomic mass is 6.9. So let's round that up to 7. So to find the number of neutrons, we take the atomic mass, which is 7, minus 3, the atomic number of protons, and that will give us the number of neutrons, which is 4. So there are 4 neutrons. So how many electrons are there going to be? There's going to be a total of 3. So we go first electron, the second electron, and the third electron then, of course, gets spilled out into the next row. If we look at the number of electrons, we break each main energy level down. The way they fill up, the smaller containers, the first main energy level only has 1 room. So therefore it can hold a total of 2 electrons. The second energy level can hold a total of 8. The third main energy level can hold a total of 18. But remember, we break them up into smaller rooms. And actually there's smaller rooms in this, so what we're going to do is we're going to just look at part of the room. So when the electrons fill in, it doesn't fill up the whole 3rd floor, it just fills up one of those sections. And what happens is we're going to say that the next energy level fills in by 8. Okay? So these electrons here, these electrons on the outermost level here are called your valence electrons. These valence electrons are super important, all right, because these are the electrons that do all the chemical reactions. These are the electrons, 99% of the time, are the ones that are involved with the chemical reactions. We're going to get talking about this later in another unit. But the law of 8, the rule of 8, I should say, talks about how all atoms want to have a full outer ring. They want to have a complete ring. So most of the time, they want to have 8 electrons in the outer shell. Okay? And then 2 for hydrogen and helium, because the first main energy level can only hold 2. Therefore, if they have 2 on the outer shell, they're considered to be full as well. Well, how do we represent it? We represent these dots, or these valence electrons, using something called the dot diagram, or the Lewis dot structure. And what happens here is, if we take a look at this element, if it has 18 electrons, we don't put an 18 dots around. We go to the rule of 8. All right, and what the Lewis dot structure is you take the element, so which element has 18 protons? So remember, protons and electrons are going to be the same. You said argon, you are correct. So we write down the symbol. This is how it's done. We write down the symbol, and then we fill in the number of electrons in the outermost shell. So these are right here. So there's 2 rules, though, that we're going to follow. There's more, but we're going to only use 2 rules in this class. That means you can only have, for the dot diagram, you can only have a total of 8. Yeah, let's try this. So for argon here, our last one, argon, for the dot structure, there are 2 rules. One is you can have a total of 8 electron or dots. And the second rule that we're going to follow is that there are only 2 dots per side. So if we take a look here, you can only have a total of 8. So argon, which has 18, and if we go back, we take a look, it has 8 electrons in its outer shell. So therefore, we're going to have how many dots? Total of 8. 1, 2, 3, 4, 5, 6, 7, 8. Now technically there is a specific order in which you're supposed to fill in those dots, but for this class we're going to let you figure that or worry about that when you get into chemistry. So let's do another one. Let's do lithium. If you take a look at lithium, lithium has 3 electrons, but the first energy level can hold 2. Therefore, there's only 1 in the outermost shell. So we only put 1 dot. And that's the Lewis dot structure.